Okay, so here they have performed some experiments on layered rocks. Like if you have a layered rock in one side of the dam, and if you have a massive isotropic rock in one side of the dam, then in what way there might be a possible slip. Right? So these are the situations where we apply different kinds of failure criteria. So in some failure criteria, you can actually use these angles, right? So there are criteria that are designed for those purposes, because it's impossible for an engineer to measure everything for each and every point, right? So they have to get the idea from a regional perspective before building a dam. So they make particular kind of calculations. On the basis of that they build these bridges and dams and these things. Okay, so for that they need some kind of equations. So these are the equations, these Moore-Coulomb equations, Tresca's, von Mises, these are the equations, Hoek-Brown, these are the equations. And there are some kind of uh, corrections also. There are lots of corrections that they use. We, as a basic structural geology course, we don't need to go to in detail with those corrections. I also don't remember all those corrections because I don't use those formulas on a regular basis. But they use a lot of corrections to make their calculations perfect, so that they won't fail. The bridges, the dams, they won't fail. So at least they know what is the limit of the before the bridge will collapse, because lives are at stake. Human lives are at stake if these structures get damaged, right? So yeah, this is very important part of in fact there is an entirely different branch of rock mechanics. So in that they are they study all these things, right? So when a rock will fail, why the rock will fail, so these things. So basically the fractures in a rock can be divided into three categories. So one is a mode one. You just tear these blocks apart. Mode 2, when you slide the block apart. And mode 3 is like just like tearing a paper, right? So it's you open it and you slide it and you tear it just like paper, right? So so fracture, they mostly they produce by this so at the tip they are produced by the mode 1 cracks, right? So initially they just form a little bit of opening, and after that when they propagate, they can propagate in mode 2 or mode 3, right? That is what we have like agreed on. Like that is how the crack should propagate it. So there are some equations that this thing satisfy. That's why this is the theory. Like so initially you get the opening of the mode 1, and then by mode 2 and mode 3 the crack will propagate, right? Yeah, so these are some again some experimental things. And yeah, so this is a plan view, the aerial view of an earthquake. So these are the radial shears on a field. Okay, so these are different kind of fractures. Yeah, questions? Questions from this part? Any questions from this part? All right. Yeah, so in a rock there are so the fracture that develop on a rock, it develops due to a particular the application of a force in a particular direction. What if those particular direction got changed over time? So instead of getting one set of fracture, you will get two sets of fracture, maybe more than two sets of fracture. Now that is dangerous for us, because we have to really know what is the spacing of those fractures, right? Or those joint systems. Those are, if there is no movement, then that will be called joint. So what will be the spacing of those joints? If you have a really big spacing, then you will the criteria that the equations we are talking about, those will be different, though the failure will be different if you have a very little cubes, right? If the joint spacing are very dense, if the spacing is very less, then what will happen? uh, so you will have definitely you will end up with more weak rock, right? So the more joints means more weak planes, that means more weak rock. But there has to be some kind of method to quantify these things, right? So people have come up with different formulas with that, and so engineers, they use those formulas. Yeah, see, this is a natural photograph. So this is one set of joint. Here you can see definitely two sets of joints, like one in this direction, another one is this direction. All right. So here one set is very prominent. So there are actually three sets of joint. One is this direction, the other one is this direction, and another one is maybe, I'm not so sure. Uh, Maybe this direction is another direction. Yeah, it's weak, but there is another direction, right? So so these things we have to study. Depending on the spacing, we get different kind of strengths. So yeah, this is the anatomy of joints. So this kind of radiating pattern we get outside the plumostructure. If you don't see it in the field, then see, this is the structure, the rib marks that we get in case of, if we open up a joint plane. So this is how you identify a joint plane. If you see a clean surface, if that's a joint plane, if you want to identify that, you have to look for these structures, right? Otherwise it can be a fault plane, very smooth fault plane. So any plane exposed on the field may not be the joint plane. If you want to identify those joint planes, you have to look for those structures, right? Okay, so there are some kind of terminologies here: columnar joints, cellulotic joints. So these are definitions. These are very detailed, written in detailed manner. So I don't think I need to explain all these things. So questions from this part? Any question from this part? Helmurugan, Joy Surjo, Suraj, any question?
Yes, sir.
Yeah.
Sir, force, which force acts on the giant causes of giant?
Extensional force. So a fracture is produced by extensional force, right? So if you apply a force that is pulling the body in the opposing direction, then it will produce a fracture in between that, right? It's just how you break a string. You just you know uh, pull that string apart, so that's how you get, so it just breaks, right? So in an extensional field, if the rock is in the extensional field, it's not the compressional field, in the extensional field, then it will produce joints. Or maybe, so I mean, the compressional and extensional field, they exist they actually coexist. So one side it will be compressive, the other side it will be tensile, right? So in the tensile domain, the fractures produce. All right.
Sir, giants on the uh, two-side force acts on.
Yeah. So see, the joint planes, uh, those are the plane. See, the x-axis will be perpendicular to the joint. So joint planes are the what should I say, yz planes, right? The x-axis will be perpendicular to the joint planes, right?
Sir, once again says the blue moose. Blue moose is a giant plane.
Yeah. Plumose is a joint plane. So, because why do we observe plumose in the field? Just because suppose in the field you are observing any plane, it can be a fault plane also, right? Or it can be just any random plane. So in the fault plane, if that's a fault plane, we will be seeing slicken lines on the top of it. If that's a plumose structure, then we will be calling that as a joint. It's not fault. All right.
சார் ஆண்டர்சன் தியரி ஃபால்ட் அது கொஞ்சம் ப்ளீஸ் எக்ஸ்பிளைன் சார் ஒன்ஸ்.
Anderson's faulting theory. Okay, so we are not quite there yet. So in the next part we'll be going through that. So I think fault, and so here you have the Anderson's theory of faulting. So it's quite, no, this is the extension, right? Yeah, so normal faults and reverse faults, so these things strikes you. So we know what are normal faults, what are reverse faults, and all those things, right? Separation and all those things. I think we all know that. Sorry, I have a sore throat today, so can't talk much. Okay, so I don't know where the Anderson faulting theory is. Do you remember where the Anderson faulting theory is? I can just draw that, this piggyback models. I can just draw that, yeah. So according to Anderson's faulting theory, the near surface, Anderson actually subdivided the near surface faults into, I mean, depending on the force distribution, he identified this faults, right? So one that is normal fault, the other that is thrust fault or reverse fault, and the other was in strike slip fault, transverse fault, I think, probably transverse fault or strike slip fault, which maybe one of that, maybe strike slip fault, strike slip, deep slip, transverse fault, maybe transform fault. Maybe it's called transform fault. Yes. Yeah. So in case of normal fault, what is happened? Suppose you have a fault. Okay, it's okay. So you are having a fault in like this in the nature. So what is happening in case of normal fault? What will happen? In case of normal fault, what will happen? Fine. Don't bother about the drawing. So this block will go downwards, right? So this block will go downwards in these two planes, and this will go upwards. This is the hanging wall, and this is the foot. This is the hanging wall block. This is the hanging wall block, and this is the foot wall block, right? This is the foot wall block. So the overall motion is along this direction, right? So he said that the x will be perpendicular to that, perpendicular to the surface, right? And the yz will be in this direction. So this is y and this is z. In case of thrust fault, so this will be z direction, this will be x, and this will be y. Because in thrust fault, what happens is that this block in the middle, it gets it moves upward like this. It moves upward, right? Okay. I think this is Z and this is X. Yes, because Z is compression, and for the thrust fault, so this is the extensional direction, so this will be X, right? And this will be Y, and this will be Z. For transform fault, Y will be vertical, and one will be Z, and one will be X, right? So, are you able to understand what I am saying? I don't think so, because if you don't understand, please tell, huh? Hello?
Yes, sir. Okay, sir.
No. Are you getting what I am telling? So depending on the different. Okay. Yes. So depending on the different orientation of this axis, so sigma 1, sigma 2, sigma 1, sigma 2, see this is maximum direction sigma 1. Okay, so yeah, I just confused with the x, y, and z. So this is the maximum direction, sigma 1, the maximum force, right? So it will be perpendicular, right? So this block will sink in, right? So this is z, this is the compression direction, this is sigma 1 direction, right? And this is the sigma 3 is the least stress, so this will be x, right? So this will be extensional direction, right? So in case of thrust regime, sigma 3 is the vertical, right? Because this will be x direction. So x, y, and z, these are strain axis, and sigma 1, sigma 2, sigma 3, these are stress axis. So Anderson's faulting theory is always explained with the sigma 1, sigma 2, and sigma 3 stress axis. So sigma 1, sigma 3 will be vertical in case of thrust regime because sigma 3 is least. That's why if you have the force on the horizontal much bigger than the force upward, then you can lift the block upwards, right? So sigma 3 has to be least. So the force that is acting vertically has to be the least force, right? That's how you can move the block upwards. And for sigma 2, if the sigma 2 is vertical, then all of these faults will be transform faults. It will just slide one past another. This is the Anderson's theory of faulting. Did you understand now?
Sir, once again, the thrust fault and transform fault.
Sorry?
Once again, say about the thrust fault, transform fault in Anderson case.
Okay. Suppose you have sigma 1 acting in this direction and sigma 3 acting in this direction. So we know sigma 1 is greater than sigma 2 is greater than sigma 3, right? This is the assumption. So there will be one line which, so this is the compressive region and this is the extensional region, right? So there will be one line in which it will be neither compressive nor extensional. So this region is compressive region, this region is extensional region. We know why, right? Because sigma 3 has the least value, right? Hello? Hello?
Sir, please, sir.
Sorry?
Understand, sir.
Yeah, so please, I mean, communicate. Otherwise, it is very difficult, because we are not in front of me. Yeah. So this is the compressive region. So the block will move in this direction. It is the extension region. So the block will move in this direction. So the net displacement will be outward. Here the net displacement will be inward. All right. So the net displacement is inward. All right. So and sigma 2 will be out of the plane or inside the plane, doesn't matter. Right. So we have to understand this diagram very carefully. Right. We have to understand this diagram. So this is sigma 1, this is sigma 3. This will be extension regime and this will be compression regime, right? So in a compression regime, what will happen? This block, so the net displacement is downwards, right? So if suppose there is a host graben structure and this block is going downward, so what will you say, that the sigma 1 is vertical or the sigma 3 is vertical? What will you say? So it is slipping like this. So what will you say? So the net displacement is downward. What will you say? The sigma 1 is vertical or the sigma 3 is vertical? What will you say? Please reply.
Sigma 1, sir.
Sigma 1, right? So for normal fault, sigma 1 is vertical, right? Sigma 1 is vertical. For reverse fault, yes.
ये सिग्मा 1 जो है सर वो एक्स डायरेक्शन के लिए होता है या फिर जेड डायरेक्शन के लिए?
What do you think?
एक्स.
Why?
तो कन्वेंशन से जियोलॉजी का मुझे थोड़ा सा कंफ्यूजन रहता है ये.
No. See, x is greater than y is greater than z. This is strain axis, and sigma 1 is greater than, right? This is stress axis, right? So sigma 1 is maximum, okay? So which means that z, so in the so the strain, that, so there are two kind of conventions, right? So in one convention, that is the engineering convention, in which you consider this compressive strength is positive and tensile strength is negative, right? Right? Hello?
Yes sir.
Yeah. So right now I am going by that convention only, right? So but there will be some books in which you will see that sigma 1 is the extensional direction. There will be some books,
तो सर
right?
इसका मतलब जब भी जो हाईएस्ट स्ट्रेस के लिए डायरेक्शन है उसको हम एक्स बोलेंगे, स्ट्रेन के लिए जो है उसको एक्स बोलेंगे,
हाँ,
स्ट्रेस के लिए जो हाईएस्ट है उसको जेड बोलेंगे. ये हमेशा सर अप्लाइड है.
हाँ.
ठीक है. अक्सर सर इसमें ये बहुत कंफ्यूजन मुझे हो जाता है ये खुद से मैं. ओके सर, समझ गया.
हाँ. Okay. Okay, so for reverse fault, if the block moved upward, then what is this direction? Is this direction sigma 3 or sigma 1?
Sigma 3, sir.
Sigma 3. So for reverse fault, For reverse fault, the vertical direction will be sigma 3, and for transform fault, so these fault planes won't be lying like this, right? It will be like that, because whenever there is sigma 1 and sigma 3, the fault, the this line will always be, so the plane at which these two planes, the line at which these two planes will intersect, that will always be the sigma 2. All right, so if your sigma 3 is not vertical, sigma 1 is not vertical, that means they has to be horizontal, right? And this line, that line that is produced by the intersection of these two planes will be vertical. That means sigma 2 is vertical for transform faults. Are we clear now?
Yes, sir.
Sorry? Sorry? Hello?
Sir, I can understand, sir.
You can understand, right? Yeah. So yeah, that will be all for today. So the next day we will go with the ductile shear and the lithostructure part, and I will suggest that all of you go through everything in the lecture of the structural geology.
सर एक सर क्वेश्चन है
Yes.
सर, एग्जाम में हम लोग के स्टीरियो नेट से भी सर क्वेश्चन आएगा, हम लोग को वहाँ पे स्टीरियो नेट से सॉल्व करना पड़ेगा प्रॉब्लम?
Tushar, do you know this thing? It will be MCQ type, right? Even if if you get the StereoNet problems, it will be just very easy. Like if you have a StereoNet just beside you, you can just visualize the whole problem. And you can do it. Like, there won't be some very complex problems about it. You have to know the basics, like so what are the angles, like in which direction, what are the axis of rotation, and all those things. Right?
ओके सर.
Okay.
सर
Anything
एक और
else?
क्वेश्चन है सर, जो हम लोग राइट हैंड रूल फॉलो करते हैं, तो सर वो हमेशा हम लोग को राइट हैंड रूल ही फॉलो करना होगा? जैसे सर कभी स्ट्राइक दे दिया हम,
Whatever you wish. So there is usually people follow the right hand rule. Okay, so you can follow a left hand rule, but you have to write that we did this left hand rule. But usually what happens, like whenever you are taking the data in the field, you do not have the time to write all like strike ends and from which direction. So usually they use the right hand rule. So this is the deep direction and this is the strike end that they note. All right, so that when you plot you won't make mistakes.
यस सर.
So that in the right hand rule you don't have to mention the deep direction of the quadrant of the deep.
जैसे हम लोग जैसे क्लास हम लोग कॉलेज में करते थे, तो वहाँ पे इस तरह का कोई राइट हैंड या लेफ्ट हैंड रूल का कोई वो लोग मतलब मेंशन नहीं करे थे,
ये ऐसा कुछ important चीज नहीं है.
क्योंकि
It's
वहाँ,
just for your convenience.
यस सर, वहाँ पे सर बताते थे कि अगर कोई भी एक स्ट्राइक दिया है तो वहाँ से 2 डिप पॉसिबल हैं, तो हम लोग हमेशा 2 लेकर के चलते थे, दोनों पॉसिबल केस करते थे
No,
सर.
no, 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 no. No, 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 no. See, the that is a little bit. I mean, I think uh, wrong, because suppose a plane is dipping in this direction, so it is not same if the plane is dipping in this direction. So this direction is fixed, right? If you are seeing a plane that is dipping in this direction, so that is the only direction that you have to plot, right? So that's why the right hand rule comes into the picture. Otherwise you have to do is you have to write down the strike, you have to write down the deep amount, true deep amount, and the true deep direction. if you
ये
write
सर,
if you write that, there won't be no issue, there will
यस सर,
not be any issue.
यस सर, जो भी क्वेश्चन हम लोग को वहाँ पे करने को मिलता था, उसमें हमेशा स्ट्राइक के साथ डीप डायरेक्शन दिया ही रहता था, ऐसा नहीं होता
And
कि
deep
डीप
amount.
अमाउंट. हाँ हाँ, मतलब वो डीप अमाउंट. सर इसमें असाइनमेंट में ऐसा क्वेश्चन मिला ना, जिसमें कि डायरेक्शन नहीं दिया था, सिर्फ डिप अमाउंट दिया था और स्ट्राइक डायरेक्शन दिया था, तो मैं सब उससे कंफ्यूज हो गया कि
हाँ, तो usually in that case people follow the right hand rule if not mentioned otherwise.
ठीक है सर।
Okay. So yeah, I'll be ending today's class. So the next day there will be no class, but that is on the 24th. The will be our final class. So I would suggest, so in that class you read everything that is there in this course, and we will discuss. We will start with the ductile part, and we will just finish for within half an hour. And the next half an hour or 1 hour, we can recap the whole course. All right.
यस
हाँ
सर।
ओके सर, यस सर,
Okay, yeah. Thank you. Thank you for joining.
थैंक यू सर।